Alright, good morning. Today we are starting trigonometric equations. So equation means an expression that involves e cosine, as you see here. Well, it's named trigonometric because you expect to see either on the left or on the right several trig functions, sine, cosine. Usually you expect to see one type at a time, but there are some questions involving several different types, like sine and cosine together. How do you solve them? Solving here means figuring out possible angles satisfying these equation. Again, the answer solution may be many. It's not, sometimes you will get a unique angle making this value, sometimes you will get several, sometimes you'll get infinitely many. Okay, so that's what we are gonna study today. Let's take a look at very simple example. This is one of the very simple examples. Can you find out what angle or angles under cosine makes 1 over 2? We know cosine is the x coordinate of a point on the unit circle. So I put the whole unit circle with significant values on it. All you need to do is figure out which points here or what angles have x coordinate 1 over 2. Which one are they? What angles? So this point has 1 over 2. Its angle value is, this angle is pi over 3. But is it only one point that whose x coordinate is 1 over 2 on the wheel? No, there is one underneath it, right here. It gives you the same x coordinate 1 over 2. This is 1 over 2. So this one also, if you go all the way up to here, this angle, which is 5 pi over 3, is also a solution of 1 over 2. So do we have only two angles satisfying 1 over 2 once entered into cosine? The answer is no. What if I add another 2 pi to this angle? I enter 1 here and add 2 pi. I mean, I make one more full cycle after this and I arrive the same point whose cosine is 1 over 2 again. I add 4 pi, that means 2 cycles, one more cycle, 1 cycle, 2 cycles. I add 4 pi here, choose n to be 2. I stop at the same value, 1 over 2. I add 6 pi, 8 pi, 10 pi, 1 million pi. No matter how many even multiples of pi I add, I always compute cosine of that angle equals 1 over 2. So we need to generalize and write all these solutions at once. This is what they come up with. N notation means n is the number, n is integers. It's not only positive values actually, it can be negative as well, including 0, 1, 2, negative 1, negative 2, negative 10, but whole numbers, but negative or positive. Okay? So this gives you all different solutions. There are two main type and they're 2 pi addition multiples. Okay? Alright? So here is another demonstration why we have multiple solutions. This is the value 1 over 2. When I draw a horizontal line, look how many locations you're crossing the graph of cosine. On this picture only, on this wheel, you have 5 different values making the same cosine value. Look, 7 pi over 3, pi over 3, 5 pi over 3, negative pi over 3, and minus 5 pi over 3. Is it only 5 though? Now if this goes up and down, you will cross more and more values. So every time you add 2 pi or more, you stand at a point, at a solution. Or you add another 2 pi to this, and you go another 2 pi, actually it's here I think. So you hit another value, 2 pi, you hit another value, 2 pi, you hit another value. So how do we write all these up again? 2n pi is all we need to add to a solution. If no restrictions are given, This doesn't say the x is an angle between 0 and 2 pi. In some questions they will only restrict the x to 0, 2 pi, then you will have only 2 solutions. But if there is no restrictions, x can be anything, then there are millions of solutions. Okay? So there isn't any new trick in this section. We are using our past trick identities, basic algebraic methods to make solutions, to find out angles, making specific equations correct, true. Okay? Here is our first question. I put down this wheel everywhere so you can refer to this for specific values of trig functions. Again, you can even get tangent here, not only sine and cosine. Alright, it says solve the equation. First thing you need to do in solving equations is prep this equation, get the trig function isolated. The trig function involved in the equation, if there is only one type, it must be all alone on the left. Now, look at this trig function. Here is your trig function. Is this thing alone on the left? No. We have several items next to that trig function sin x. So you need to get rid of those blue things. Which one is first and how? There are two. 2 and 5 root 3. Which one do we get rid of first? Yeah. We start with additions, then multiplications. I will wipe that 5 root 3 off by simply subtracting it from both sides. Okay? You will have 2 sin x equals gun. What is 6 root 3 take away 5 root 3? Remember how you add or subtract radicals. You only add or subtract the numbers in front of them and copy the type of the radical. So the type of the radical is root 3. 6 take away 5 is 1. If the answer is 1 or minus 1, you don't have to show that, only radical is sufficient. So this is it. Now how do I get rid of 2? Divide both sides by 2. We have sin x equals root 3 over 2. Alright, is the trig function all alone? Complete all by itself, right? So it's time to make determine x. Axis actually. There may be several. So sin x means y coordinate of the points on the circle. Which points on the circle have y coordinate root 3 over 2? Which ones? Which angles? 120 is first. Here we go. So 2 pi over 3 is our first guy. I'll put it here. What else? 60, which is pi over 3. Okay? Always please prefer the radian measure, not degree. Alright, is this all? Is this the final answer? There's something missing. You need to find all of them. You just found 2. You need to use n to get all repetitions. Right? Because if you make another full cycle and you stop here, another 2 pi, that's a solution as well. And you continue and make another 4 pi, addition to 4 pi, pi over 3, you make another stop and you another same value. So we need to start adding things to this. What are we adding? 2n pi, 2n pi. As n, whereas we add multiples of 2 pi into the angle and still end up with the same sign. Alright, how do we enter this to our system, homework system? First, you find the answer from 0 to 2 pi. That means they are demanding these parts. These are from 0 to 2 pi. The values showing up directly on the wheel are 0 to 2 pi, so they want them pi over 3 and 2 pi over 3 first. Next, we need to put down the general entire set of solutions, which are as pi over 3 and all multiples of n added to it. 2n pi, 2 pi over 3, and 2n pi. You can use the regular pi symbol or type it in as I did. Okay? Any questions? So far so good, huh? Because this is easy, just single trig function, numbers around it. It was easy to get it ready for the final stage. Now this one looks even easier, right? Now there's going to be a challenge somewhere. Let's see where. Okay, first thing we're gonna do is get sine isolated. Let's get sine all by itself. What do you see next to sine? 5. I need to get rid of it by subtraction. Gone. Sine 3x is -1. Alright, now, just for, okay, is this completely isolated? Yep. Let's figure out, just imagine this as a theta, or y, or z, or any other letter. You are figuring out an angle whose sine, theta, is called theta, whose sine is -1, whose y coordinate on the unit circle is -1. Find those angles, angle or angles. Which angle or angles have -1 on y coordinate here? Which? Right, this one, right? Look, -1. Alright, so it's 3 pi over 2. Put it down here. But what is this 3 pi over 2 equal to? Theta. What was theta? What was behind theta? What is theta covering up? Theta is 3x. Did they ask us to solve for 3x? No. They want solve for x. They want us to solve for x. X needs to be alone. This is triple x equal to 3 pi over 2. Oh, by the way, when you are at this stage, please add this one too. It's not only 3 pi over 2 making -1 under sine. All addition of multiples of 2 pi as well. When I make a full turn, 2 turns, 3 turns, always I stop here and make the same y value. So don't forget to add this right here. And finally, we need to get x by itself. So how do I get x by itself? Yeah, we divide both sides by 3, which is going to divide both terms by 3. When you divide 3 pi not only by 2 but 3, it means combination of these makes 6. 3 pi over 6 and 2n pi over 3. Okay. Alright, please simplify if possible. Isn't 3 pi over 6 equals 2? Right? So it's just pi over 2 plus 2m pi over 3. All 90-degree angles here, 90 degree. And when you add 2 pi over 3, 4 pi over 3, 6 pi over 3, 10 pi, 8 pi over 3, all multiples of 2 pi over 3 added to 90 makes this thing 4 under sine. When you add 5 and add sine 3x together, they make 4. If you like, just take a value of n like 10, add these up, put it in calculator, triple it and put it in calculator, add 5, it's gonna make 4. Just take a sample value if you wish. I'm sure this is right. So it's pi over 2 and 2 pi over 3. That's so. 2n pi over 3. Okay? Alright, here's the second part coming up. This is the general solution, but they request the values. You choose n, and it can be 0, 1, 2, -1, -2. I want you to choose n values so that x will stay from 0 to 2 pi. Part 2 is find all x's that stays from 0 to 2 pi. Right? That's what it says here. 0 to 2 pi is not included. Except 2 pi, start with 0, but don't include 2 pi. So what we need to do here is take various x values and compute. So I take n equals 0 first. What is x? Pi over 2 plus 2 times 0 times pi over 3, which is just pi over 2, right? Correct? When I put 0 here, it's just pi over 3. So is it in this range? Is 90 degrees from 0 to 360? Yes, so this is a check mark. So I will include this in my solution right here. So it is first pi over 2. Let's see if there are more. I will test n equals 1. So I will get pi over 2 plus 2 pi over 3. Set the common denominators, multiply this one by 3 and this one by 2 and add. This is 7 pi over 6. Is 7 pi over 6 between 0 and 360? We need to have it from 0 to 360, right? Is it? Is 7 pi over 7 pi over 6 less than 360? Yeah, this is pi over 6 is 30. You have 7 of them. That's 207. 210. 210 is less than this, so this is a check mark. 7 pi over 6 is there. Once you're out, it's hard to go back in. 7 pi over 6 is the next guy. Do we have more? Until I'm out of range, I will try positive and negative n values. Like I will try 2 next. That's pi over 2 plus, when I plug in 2 here, is 4 pi over 3. Well, I need to set the common denominators one more time. This one by 2. So they make 6 in the denominator. 6. At the top is 3 pi, 8 pi, 11 pi over 6, right? Am I right? Is 11 pi over 6 less than 360? Yes, because it's 330, right? 330. Yep, I caught one more fish. 11 pi over 6 is here. Wow, how many are we gonna get? Let's keep counting. How about n equals 3? X equals pi over 2 plus, if I plug in 3, this is 6 pi over 3, that's 2 pi. Well, this is obviously more than 2 pi, right? Because 360 plus 90 is, this is more than 2 pi, or 360. So this doesn't count. False. So stop. Don't check n equal 4, 5, 6, because you're gonna get bigger and bigger, right? So is this all? Are we done? We went beyond 360, so shall we stop? Yeah, we will stop in the positive direction, but we haven't checked the negative n values, so I will go forward in the negative direction next. So n equals -1 first. X is pi over 2 minus 2 pi over 3. Set the common denominators 3, 2, that's minus pi over 3. Alright. 3, no, that's positive pi over 3, right? Am I right? No, I'm wrong. It's negative pi over 3. Okay, so is this a good solution? Shall we count this in our solution set? Shall we? Why not? Yeah, it says 0 to 2 pi. If this would be a positive pi over 3, I would take it, but it's negative. It's not from 0 to 360. I stop, and I don't even check minus 2 because I know it's going to be more negative. When I plug in minus 2 here, minus 4 pi over 3, it's going to be worse than this. So whenever I'm out of range in the negative one, I cancel it as well. So we have only 3 solutions. These. Let's get rid of that extra comma so we don't cause any trouble. Okay? Ascending order. Is this in ascending order? Yeah, I'm lucky. Okay. Any questions? So you first get the general solution with n's, and then you start substituting n values. Starting with 0, 1, 2, 3, until you go out of range. This is 2 pi is the maximum. And you also go in the negative direction, negative 1, negative 2, negative 3, until you drop lower than 0. And in the first step, I got lower than 0, so I stopped already. Okay? Make sense? Alright, how about this? I'll give you a couple minutes. Any values you found? Or anyone? Okay, let's do it together then. First, we need to get cotangent all by itself. So I'm dividing both sides by root 5. Look at this, they are canceling completely, and this is 1. So kind of that root 5 is given for distraction, to distract you and make the equation look like challenging, but no, this is the real equation you have. Okay, just imagine there is an angle here whose cotangent, you're gonna find angles here, whose cotangent is 1. Well, what's the meaning of cotangent? Now this table is for sine and cosine values. Remember, this is cosine, this is sine. Cosine, sine. How do I get cotangent values? Just think, what's that? Yeah, think cotangent as cosine over sine. Cos, sine. So you're looking for an angle here, cosine of an x over 2, an angle. Whatever angle is here, their ratio is gonna be 1. So you take two values here, take their ratio, like 1 over 2 and root 3 over 2, and it has to be 1. For example, can this be this angle? Is ratio of 1 over 2 and root 3 over 2 1? No way. This is 1 over root 3. So when a coordinate or this terminal point, an angle, may have their coordinate ratio 1, which point or points may have their ratio 1? When does it happen? If they are the same, of course. So only thing you need to check out here on this wheel is which points or angles have x and y coordinates matching. Which ones have? Pi over 4, yes, what else? Is this gonna be taken as well? No, this is opposite sign. We need the sign matching as well, not this one. And we have one more, which is this one, right? Negative, negative cancels to positive 1. Not this. So you have two angles who makes 1. Those angles are first pi over 4 2 pi n to n pi, or x over 2 must be 5 pi over 4 to n pi. Agree? Do you agree? Alright, what is next? Remember, we need to get x by itself. You found x over 2. So whatever you have inside, you set it into these angles, you spot it, making cotangent 1. Now we are going to get rid of this half, 1 x over 2. What operation do you need to make? Multiply by 2. Like that. Is that right? So x is, oh, these two cancel, makes pi over 2 and 2n pi. Or x is 5 pi over 2 plus 2n pi. That's it, correct? Where's the mistake? There's a mistake. Yeah, there is a parenthesis, and this 2 not only multiplies the first but second as well. So this is gonna make second one 4. Same thing. I will multiply the second part by 2 and make this thing 4. Okay? Alright, I think this is it. Pi over 2. Now I forgot. Do we need to set this into x equal? Yeah. Pi over 2 plus 4n pi. X can be also equal to 5 pi over 2 and 4 n pi. Am I right? Is this what we got? Oh no, let's check. Did I mess up? Where is the mistake? So let's make this rule. Whenever you multiply both sides by a whole number, then the solutions can possibly reordered, combined into simpler notation. So when you take the numbers on the left and right and put it in ascending order, they may follow a new pattern, simpler pattern than these. It's just 2 pi more than pi over 2 every time. We just need to combine them back into one formula instead of writing twice, 2 separate. Okay? So that's the mistake we did here on this question. Now, taking this right solution, we will in part 2 identify which one of these solutions fall into 0 to 360 range. So I will choose some n values here and compute them. For n equals 0, we have pi over 2. For n equal 1, When I add 1, it's already 2 pi more than 2 pi. This is false. So I have one solution already. Let's try the negative value. When I enter negative 1, so it's pi over 2 minus 2 pi, which is less than 0. This is false as well. We only want 0 to 2 pi, right? 0 to 2 pi. So there is only one value, which is pi over 2. Okay? Alright? Alright, here is another lesson we got. If you have, this is when happen. This is if you have a ratio type of equation, x over 2, and your angle is divided by a whole number, eventually we need to multiply both sides and combine solutions into better format, simpler format. And besides, usually we get 3-4 different solutions. If your angle is divided by a whole number, you usually have less solutions. You see, it's just one solution. Okay. So this was a good one. Even tricked me. But our initial solution is not correct. It's not false. This is still a valid solution. It's not in the most compact way written. We just reordered them and made it better. Alright, next. We have another cotangent solution equation to solve. But this time, I'm glad x is not being divided by a number. If there was a number, we would have to do the same trick. This time x has subtracting a number, so that's no big deal. This is not something we need to scare off. But again, we need to get cotangent all by itself. So I will put the 3 to the other side, root 3 to the other side as minus root 3 first. Next, imagine this is your angle theta. Find out what angle, ignore pi over 2 or x, just there is an angle on the wheel whose cotangent is gonna make minus root 3 this time. This is tricky. So you need to start dividing cosine and sine and see which one makes minus root 3. So I know it's not this one. This makes 1. Cotangent of this 45, cotangent pi over 4 is 1. How about this one? 1 over root 2 over root 3 over 2, they cancel into 1 over root 3. That's root 3 over 3 if you rationalize the denominator, multiply both sides by root 3. Nope, not that one. False. How about this one? This makes root 3 over 2, 1 over 2 makes root 3. We're almost close, except the wrong sign. This is not true either. So I will switch to this side and quickly check out this one. Minus root 3 over 2 divided by 1 over 2 is minus root 3 if you cancel these. Wow, okay, I caught one fish. Theta is, what is this angle? 5 pi over 6 plus 2n pi. Okay? Or, what is the other value? Is this the only one makes? Usually it's the opposite side you need to check out. What is this one giving you when you divide x by y? Cosine over y is, cosine over sine is negative root 3 as well. So 11 pi over 6 2n pi. Okay. Alright, watch out again here. There may be again we may need to again rewrite ends. Alright, so I will double check. Alright, what was theta though? We're not looking for theta, we are looking for x. Theta was x over minus pi over 2. So we need to get to x by isolating it. This is as well x minus pi over 2 equals 11 pi over 6 plus 2n pi. Now I need to get x alone, so I will add both sides pi over 2. Okay? To cancel minus pi over 2, I'm adding both sides pi over 2. Oh, maybe this is better. Add it right underneath it. So you see the cancellations. X is, what is 5 pi over 6 plus pi over 2? You need to get the common denominators. 5 pi over 6 plus pi over 2 is, multiply both sides by 3 and get common denominator 6. 5 pi plus 3 pi is 8 pi. Reduce these 4/3. 4 pi over 3 is the first one. Okay. Now this guy is 11 pi over 6 plus 3 pi over 6 is 14 pi over 6. It's 7 pi over 3. Again, here's the details. 11 pi over 6, add pi over 2. Set common denominators, multiply the second one by 3. 3 pi plus 11 pi is 14 pi over 6. Divide both sides by 2, and this becomes 7. This becomes 3. 7 pi over 3. Alright, we need to reshape our solutions. Again, I will do the same thing I did here. See if I can combine two solutions into one notation like this. Isn't there a pi difference between these two? We're always adding 2 pi. And this is pi over 3. Okay. Do you see something going on here? We need to find out most economical way to list all these pi's. Because ConnectMath may be asking for the best way, most simplified way. Okay, so let's get, it looks like, do we have multiple solutions? It doesn't, seems like single solution though. We must find a way to combine these solutions. Okay, let's first put 0. We get 4 pi over 3. Now put 1, or I know some you guys don't like fractions, you like angles better. If you can find that pattern with angles, that's even better. So 4 pi over 3 is, when you change into angles, this is 5 pi over 3 is 60. 4 of them is 240. So this is 240 first when you put 0 in n. When I put n equal 1, this is 360 plus 240. What is 360 plus 240? 600. And then I add another 360, that's 960. Add another 360, that makes 1380 or 1280, right? So 1320. This is sufficient. I got 4. Let's check out this one. Plug in, this is 60 times 7, 6 times, this is 60 times 7 is 420. So we start with 420. And then I add 360 to this, 360 to this, and I get 780. And and I add another 360 to this, and I get 1140. Add another 360, you get 1500. Alright, now I order this, combine these solutions and order them in ascending order. For first 240, 420, and then 600, 780, 960, 1140, 1320, 1500. What is the difference between each? Can you find the pattern between each angles? What is it? Come on, you must see it. 180. Yeah, perfect. So every time you're increasing by 180. But what is the initial amount you started with? 240 plus you're adding multiples of 180, n times 180, right? So turn this into now radians. What was 240 equal to? 4 pi over 3 plus n, this is 2 pi, no, n pi now. See, I combined two solutions. These are final results. Rather than representing in two different equations, we combine them into one. How did I do it again? This is called pattern finding. I found the solutions, 4 of them. You can do 10 if you wish. I found another 10 of these solutions, and I lined them up from increasing order and seen a pattern between them. They are all increasing at 180. Alright, let's see if this is which one connect math wants. 4 pi over 3. Or maybe, okay, I want to give you one more solution. What do you think the previous one before this one will be? Oh, there's a better solution. I mean, you know, this end goes indefinitely to the left, right? What is 180? What is the solution before 240? 240. It's 60, right? Pi over 3. And what is the solution before this? It becomes negative now, right? Minus pi. Pi over 2 pi over 3. No. Yeah, if I subtract minus 4 pi over 3 from this, no, pi from this, I don't know, okay. 180, it's I think minus 2 pi over 3, yeah. It's negative, we don't care. You could write your answer as pi over 3 plus n pi. This is also a solution, but we need to go with the minimal value. I think this is what ConnectMath is gonna like. You need to go with the smallest positive starting value, which is this one. This is negative. So I will enter pi over 3 instead of 4 pi over 3. In the directions we don't see that, but I'm just going with the conventions, mathematical conventions, traditions. We always go with the smallest angle, positive smallest angle, and start increasing it at 2 pi or pi, whatever the pattern period of increase is. Yeah, it liked this one better. I wonder if it's gonna, yeah, I can't go back. I was gonna try 4 pi next. Okay? So again, what is the strategy? Unfortunately, what I did here is just tradition. The right solution is this, but this is not the best way to represent your solution. So we see a pattern, we seek a pattern, and find the smallest positive angle, it makes our equation correct. It's pi over 3, not 240. Although we started with 240, it's lower than that. So I start adding it into n pi's, not 4 pi over 3, but pi over 3 is the starting value. Okay? So these cotangent questions are unfortunately like this. Yeah, it's not as easy as sine and cosine. Alright, and we need to spot some values from 0 to 360. It's already here. What are those values from 0 to 360? Here is 1, here is 2, no more. There are only 2. Pi over 3 and 4 pi over 3. There are only 2 solutions in the range of 0 to 360. Okay? Any questions? Alright. I think we can do one more question here. It involves cosecants this time. Wow, what a mess. Now for the first time, we have cosecant x, of course. This is the first time we have cosecant, but for the first time you have something else. What is different? Comparing to first 4 questions. What stands out quite different other than cosecant? There's a square. Also, another ways to say this is there are 2 locations with the same trig functions. 1, 2. Look, all the time in the previous questions you had a single trig function. Single trig function. Single trig function. Single trig function. One trig function, one type. This is also one type, single type, but it pops up in 2 different spots. Cosecant here, cosecant there. So that's one warning sign. And the second one again, yes, especially as one of them has a square, so we cannot combine them. There is no way I can combine these 2. Because first one has a square, the second one does not have any square. Alright? So what shall we do? Any ideas? Remember, solve this x means you need to get cosecant isolated from the other group. Get cosecant alone. This is our target. Get cosecant x alone on the left side. Like this. This is our target. We need to kill all separate cosecants, separate them. How can I get cosecant isolated? Then we can decide its values from the wheel. Cosecant is 1 over secant, etc. I'm sorry, 1 over sine. And we can get that value quickly, but give me a recipe to find cosecant on the left. Any ideas? Alright, I want you to try a substitution. Replace the trig function cosecant with a symbol of your choice. And in math, whenever you need a substitution, we use this letter. It's U we choose. I don't know why math people like U. Recall, whenever you replace a function or an expression with something, we go with U. Can you make every cosecant U here? Or you could call this theta if you want, but theta is usually for angles. I will call it U. Again, you have square of cosecant, so cosecant square turns into what? If cosecant is U, it becomes U squared, right? We have 5 of the cosecants. Each cosecant is called u from now on. So this is my selection of, I made this name. So cosecant is now declared u. I call it u. Now look what your problem turned into. This question, a trig equation problem, pre-calculus course question turns into college algebra, elementary algebra course. This is what you've done in 1148, previous course, or even before that, 1075, or even elementary school. So you've seen quadratic equations. Right? Now how do you solve a quadratic equation? Or trinomial set into 0? 3 terms set into 0 with one of them have a square is solved by factoring. Yes. We need to separate them into 2 groups. And 2u squared, 2 separates as 2 and 1. U squared will be u and u. 2u times u is 2u squared. Important part is, how do you split this 2? When you FOIL this thing, multiply outside and inside terms and add, they need to make minus 5u. So how does 2 separate here? 2u minus 1, u plus 2, minus 2. It can't be plus 2. It should be minus 2 because when you multiply these two numbers, minus 1 and minus 2, they need to make positive 2. So my initial value, positive 2, was incorrect, so we fixed it. Now we still need to check this. 2u times minus 2, is it minus 4? Minus 1 times u is minus u. When you add these like terms, do they get minus 5u when you FOIL it? Yes. So we have the right factoring here. 2u minus 1 minus 2. Next, we set each into 0 and solve for u. Right? That's how we solve quadratic equations. Alright, I will add 1, 2 to both sides. 2u equals 1, u equals 2. Next, I will divide both sides here 2. And voila, 1 over 2. And this trick doesn't require any trick. Are we done? You solved for u, and the other, whoever requested this question, will say, well, I'm expecting what x is or cosecant is. You gave me u. What is u? We don't know u, right? Well, we do. U was something you made up. You need to take it back. What was u? You made it up, right? U was a replacement symbol for what? Put it back now. What was it? Cosecant. So put cosecant back in place. Right here as well. Okay? Now, do you guys know what angle under cosine makes it 1 over 2? Do you? From this table, can you find those values? No, I can't. This table is for sine and cosine. I can get tangent, cotangent. Cosecant is too challenging. So what do you think you're gonna do next? If cosecant is inconvenient, it's not useful, then flip it. Change it into 1 over sine. Alright, I need sine on the top, so I will flip both sides. Flip. Wait, this doesn't have anything to flip under it, right? No, there is. It's 2 over 1, so you can still flip both sides. Flip both sides. Sine x is 2. Sine x is 1 over 2. Now, you need to make a comment right now. Right. There is no solution here. Because sine can only take values between -1 and 1 on the unit circle. None of these numbers here for sine, these are sine values, are more than 1. The maximum they can make 1 and -1. Everything outside is between 1 and -1. So this was a dead end, this direction, but there is still one side you can work on. What angles, there are I believe 2, make sine 1/2? Pi over 6, and there's one more. 1/2, 1/2, where are you? There you go, pi over 6. The other one, 5/6. Alright. Good news, they do not want general solution. They want two solutions from 0 to 2 pi, and you already found them. Are there more? Maybe you add these 2n pi's and 2n pi's and substitute n values, but I don't think you will find any more. No. Try -1, +1, you will be beyond 0 and 2 pi quickly. So these two are the solutions for this question. Oh, come on. Yeah. All right, we'll continue this tomorrow.